So how can we solve trigonometric equations of the form a cos theta plus b sin theta? To solve such equations, we have two methods which we can use. And to understand these methods, we just need to have some look at some examples. But the methods are these ones, and I'm going to explain both of them. Let's look at this example and see how we can go about using these methods. This example is telling us to solve 7 cosine of theta plus sin theta equal to 5 for values of theta from 0 to 360 degrees. Now what we are going to do, let's do this. We shall let 7 cos theta plus sin theta equal to r sin theta plus alpha. We are first of all going to work on that part, then we work on that part. From the first part, we are going to get the value of r and the value of alpha. Let us expand r sin into theta plus alpha. That's what we have. And now we shall open the brackets. And we come to, now we have this. Let me highlight the terms in cos and the terms in sin so that we can see. Now we have the terms in cos. On the left hand side we have 7. On the right hand side we have r sin alpha. The terms in sin, on the left hand side we have 1. There is nothing, there is 1. Then on the right hand side we have r cos alpha. That means that I can say that r cos alpha is equal to 1, and also r times sin alpha is equal to 7. We look at the r, the sin alpha, and the 7 as the terms in cos theta. So we come to this, that is r sin alpha equal to 7 and r cos alpha equal to 1. And now from here we can solve for alpha by getting equation 1 divided by equation 2 and find the value of alpha. R sin alpha divided by r cos alpha, you get r cancelling r, and you have tan alpha equal to 7 over 1, which is equal to 7. And now after that, what we need now to get is the value of alpha, which is the tan inverse of 7. So alpha is equal to a tan of 7, which is giving us 81.9. We can also see that if I get equation 1 and if I square equation 1 and add it to the square of equation 2, I can get r squared cos squared alpha plus r squared sin squared alpha. And when I pull out r squared, I have cos squared alpha plus sin squared alpha into the brackets, which is equal to 1. So that means that r squared is equal to 50, and r itself is 5 root 2, the square root of 50. So remember our equation was r sin into theta plus alpha. So we now have r and alpha. So we know that this was our assumption, that 7 cos theta plus sin theta is equal to r sin into theta plus alpha equal to 5. Now we have just got the value of r and the value of alpha. So now we are going to leave the left hand side and we are going to work with now the right hand side. We are now going to work with this. Having got r and alpha by using this side. So we had that. Now we are shifting that to the other side. Now we are going to substitute. We have that is upon substituting, we have substituted for r. We are using that. R is 5 root 2. Sin theta alpha is 81.9 equal to 5. Now we shall have divide through by 5 root 2 If I do that, shall have sine of theta, sine into sine of theta plus 81.9 equal to 1 over root 2. So we shall get the arc sine of 1 over root 2. The arc sine of 1 over root 2, that one is going to get us 45. Arc sine of 1 over root 2 is 45. We have another angle in the second quadrant. There's another angle in the second quadrant, which is because sine is positive. That means that we are going to work in the first quadrant and the second quadrant. We can also have this angle. That angle is the same direction as 45. We get it by having one tan added to 45. You can see that to get theta, you must get the angle which you have here. You have these angles and you are subtracting. You are going to subtract 81.9. And remember, the range, our range is supposed to be from 0 to 360. We don't have negative values of theta. We have 53.1 and then 323.1 degrees. Those are the values of theta that satisfy our equation. Peace. The second example is here. We shall let the left hand side to be equal to r sine into theta plus alpha, like so. And then, of course, it is also equal to 2 because everything here is equal to 2, and even what we let here is going to be equal to 2. And now we are going to expand the r sine, like so. And after expanding that, I'm opening the brackets and I'm writing the whole equation so that we can see it clearly. So we have that. I highlight so that we can see the terms in sine theta and the terms in cos theta, how they are going to separate. The terms in sine theta, on the left you have root 3, r cos theta equal to root 3. And then r, the terms in cos theta, we have cos theta there, that is 1. And then cos theta this side, we have r sine alpha. So that gets us to this supposition. You have this. So r sine alpha equal to 1, r cos alpha equal to root 3. If I get root 2, if I get equation 1 divided by equation 2, I'm going to get that tan of alpha is equal to 1 over root 3, and alpha itself is equal to arc tan of 1 over root 3, and that one is equal to 30 degrees. The next thing we need to do is to get these two equations. Get equation 1, square it. Get equation 2, square it. Then add the squares of the two equations together. So from there, we are going to have this. This is what we have. Equation 1 squared plus equation 2 squared. It can get us these values. R squared equal to 4, implying that R is equal to 2. We have now got the value of R and the value of alpha. So we now have everything written there. This one equal to this. We have used this one. What have we used? We have used this to get the value of R and the value of alpha. Now we are going to use these two to get the value of theta. Shall use those to get the value of theta. So here we are. The expanded version, we are substituting for R and alpha, and we have that one. Divide through by 2, and you get this. Sine into theta plus 30 equal to 1. Then, after that, theta plus 30 is equal to arc sine of 1, which is equal to 90. Sine theta is positive in the first and the second quadrant, and in that case, when the sine theta is 1, we have only that angle in the two quadrants. And now theta is 90 minus 30. Boom. That is what we have as the value of theta. We have only that value.